Hi, everyone, and welcome to the first ever Keras Community Day Sub-Saharan Africa event. My name is Ada Nduka Oyum, and on behalf of the Developer Relations team for Sub-Saharan Africa at Google, I'm excited to welcome you all. The Keras Community Day event, also known as KCD, is a series of events focused on Keras and machine learning, which is also led by machine learning communities across the world, including Google Developer Groups, GDGs, Google Developer Student Clubs, GDSCs, and TensorFlow user groups, TFUGs, and also other third-party ML communities. This is the first Keras Community campaign operated in joint efforts with the Keras product team and the ML developer programs team at Google to bring Keras closer to the machine learning community. Once again, on behalf of myself and my team, we're excited to welcome you all to this live stream. This KCD event is going to be in two versions. Today's one is the English version, and next week, Saturday, we're going to be having the French edition as well. I am excited to also bring on the GDG Lagos team, who we've been working together to co-organize this for all the GDGs and other third ML communities in Sub-Saharan Africa. So please welcome Bolahon and Marianne. Hi, Bolahon. Hi, Marianne.
Hi, Ada. Hi, Bolahon. Hi, everyone.
Hi, Marianne. Yes, please go ahead.
Hi, everyone. I'm Marianne Onoha. I am the co-organizer for GDG Lagos, and I also lead the WTM Lagos chapter here. We're so excited to have everybody here. We've been planning, we've been getting things together, and it's the day. So I won't take much of your time. I'm just going to go straight to the point. Welcome to Keras Day Community live events, the first one ever, just like Ada said. And I will be passing the mic down to Bolan.
Okay, thank you very much, Marianne. I think Bolahon is unavailable to join, so I will just call on Lekon Rahim, who is going to be the host for today's event. Hi, Lekon.
Hi, Eda. Hi, everyone. Thank you. I'm excited for this event. I've been looking forward to it for a few weeks now. Finally, we're here. I hope everyone is good and we are going to have an exciting time. But before we get started, we are supposed to have an address right from the Google team. I believe, Ada, would you like to do that, or are we done with that?
Hi, bro. Hi, Lekon. Yes, I already gave the address as the intro, so I think we can get ahead with the live stream.
Okay. Is Diana here? Are we ready?
Yes, hello.
Oh, great. Thank you. It's a privilege to have you, and we all look forward to your session. Are we set? Right?
Yes, just let me share my screen. Let me just share my entire screen. And then hopefully it should be good on your side. Can you see my screen?
Hi, Diana. Yes, we can see your screen. Please go ahead. Thank you.
Okay, awesome. So, hi everyone. My name is Diana Mudeu, currently based in Nairobi, Kenya, and mine is just to thank the GDG Lagos team for organizing this wonderful day, just bringing Keras to you and the feel of Keras and what it has to offer to the developer community, especially the data side and the software and ML engineers. So basically, I'm also a WTM ambassador, WTM Nairobi. WTM is one of the groups under the Google Developer Groups, and I work as an associate data scientist. So basically, just at the start of my career in data science, and I'm hoping that I get to share what I have picked up and learned about Keras NLP with my trials for the past about few times. So basically what we'll start with is what is NLP, not diving so much into it, because again, it's a highlight of Keras and what Keras can do for natural language processing. Just a slight refresher or general introduction on what NLP is, then moving on into going into the 3-feet pool with Keras, just understanding exactly what Keras is. And then now we look at what Keras NLP is, where did it come from, what exactly is it, what connection does it have to Keras, but the name definitely says it, but just to give that understanding, then diving again slightly deeper into Keras NLP, then taking it for a spin, and then I'll lay out a map for you for your next journey in natural language processing using Keras. So I'll start off with this quote that I found by Ludwig. So the limits of my language mean the limits of my world, right? So if you have limited understanding and communication, right, of each other, then there's a lot that you get to limit yourself in terms of either doing trades. In this case, maybe, for example, trying to understand your customer base. For example, let's say your product, you build a product. These days, products are not built for a single country, right? They're built for example, the entire of Africa, Sub-Saharan Africa. We speak different languages. The way we interact on Twitter is completely different. So this might be a limit in terms of even marketing and growing your brand if you do not actually understand the customer base or the customer feedback that is coming either through social media listening. And that's where NLP can actually come in and help you in terms of thriving and understanding your customer base, understanding their feedback and making it better. So basically, natural language processing, NLP, in short, which I'll be using as we go. Hopefully, I'm guessing there's a mix in the team of beginners, advanced, and intermediate. So NLP basically is what you're typing that is online, what you've put out there, anything that is written. So basically that's your natural language first, right? That's the natural language. In this case, we're talking in terms of how the computer is saying it. So the computer sees it as the natural language or the human language, right? And as you know, computers do not actually understand how we speak. We have to convert it into numbers of binary text so that we can be able to actually have it process, understand, either generate what it's supposed to generate. And then from there, we can be able to achieve our goal if it's either classification, text classification, or building items or cool items like ChatGPT, your large language models. So you can see either your articles, what is coming from your social media, what you're posting, any place, whether it's an email that you're writing, all this is still termed as human language because one, they do not actually understand either English, French, German, or your local language. It's a bit difficult. So in the phase or in the terms of artificial intelligence, which was mentioned like 1 million times during Google I/O, so where does NLP actually come in? So using artificial intelligence, and that's what we're going to see today with Keras. So in this case, where AI is, place in Keras on there as a framework. And then human language is now what we're going to be extracting, or the data sets that we're going to be using. And then the concept of computer science from object-oriented programming, or basically just programming on its own using Python. In this case, we'll be using Python. Whatever sits in the middle here for these three to communicate is what we call natural language processing. So the ability of computers to actually process human language, right? Using, in this case, we'll be using Keras, and then the concept of maybe programming, that is Python, and for example, modular design. So looking at what natural language processing entails, we have NLU and NLG. So basically these two could occur separately, right? One, especially when it comes to natural language understanding, I'll give you an example because processing encompasses understanding and then being able to actually generate something. So for example, natural language understanding, back to the example that I gave you, you perform social media listening, for example, you're trying to analyze Twitter data about your product X that you launched, or maybe a certain movie Y that people reviewed on, and you're collecting that data set. So all your model needs to do is just perform natural language understanding and then be able to, if you're trying to classify maybe in terms of sentiment analysis, is it positive or negative? And that's it. And then it can be able to predict that. It stops at natural language understanding. Then let's look at now the second aspect of it. After it's understood, then what next? In some cases, we move to the natural language generation. For example, ChatGPT, that one, Bard, for example, by Google, you need to actually check out Bard and see how it's pretty cool. Natural language generation just exploded, with the emergence of large language models being able to actually communicate with a computer and it being able to actually generate and speak the human language. Right, so we've looked at what NLP is. Now let's take a deep dive of where Keras sits in all this, right? We've looked at achieving natural language processing to build, to do sentiment analysis, building of chatbots, building of translators that you can do voices to, and it actually responds to you, such as Alexa. So Alexa probably, it does the understanding. So Alexa, can you switch off the music? And then it switches off. So basically like that. Also just looking at your basic text emails that you produce these days, that you actually do these days. So there's a lot of text prediction that happens. So if it's maybe hello, it's already picked up the name of the person that you're trying to send the email to. So yeah, that's pretty cool. And we'll try and also see today how Keras generation happens in the introductory bit of it, and how to build a generative workflow for text prediction using Keras. All right, so we start with what Keras is. So it was basically developed in about 2015, right? And the reason for this was actually it started as a research project because of the issue with the complexity that TensorFlow had, and most deep learning frameworks that were available at that time, they were a bit too complex, and then not beginner friendly. So beginners found it quite hard to get into deep learning because of the existing frameworks at that time. And then, so it's a high level API, so an application programming interface. I'll just label this out what it is, and then in case you're a beginner, you can just check it out. So it's built on top of TensorFlow. So basically that means the source code of TensorFlow contributes to what Keras, the Keras capabilities, just that Keras is in a simpler and much faster, a bit faster version of TensorFlow. And then it's fully free and open source. So open source means that you can actually contribute to the community and to the source code of Keras, right? To the community and Keras aspect. All right, so what are some of the features Keras to make you consider it as your first and last framework, right? So from end-to-end deployments, why should you consider Keras? So one being the large community that it has. I have attached some links on this slide. Hopefully you do get access to the slides for you to actually see the community that is there, and being able to see what others are saying about it. So an access to a large community means that if you're having any trouble with utilizing the given framework, there's someone who's coming to help you, right? And then the other concept is a pretty strong documentation. And there's this meme that says developers they save 6 hours of debugging for 5 minutes of using the documentation, right? So it's supposed to be the other way around, but you find most developers spend so much time on debugging instead of actually hooking up into the documentation, which has been perfectly written by the engineers who engineered Keras to help you understand what is happening within the framework. So hopefully after this, you'll actually use your documentation just like your drivers or a mechanic has their manual for a car and the chefs have cookbooks, then developers have documentations. Make sure you actually use that. And then it's production ready. That means that Keras actually has the full TensorFlow ecosystem from TPUs to your DTensor to TensorFlow JS. That means our TensorFlow Lite, where you can actually build mobile interfaces on. And then DTensor helps you in terms of large language models that will see processing large batches of language. And then it's definitely extensible. With your own activation layers, models, and existing base building blocks for everything. All right, so that's a 3 feet deep into Keras. Now on to the next item will be who exactly is Keras NLP? When did it come into life or into phase? What does it do? And then we'll see how to go about that. All right, so getting started with NLP was quite challenging, and the source code was really large. I wish I had opened my GitHub for you to actually see what NLP looks like without actually using a deep learning framework, and how complicated it actually is, and the steps that you need to follow to get to your desired output, if it's maybe prediction, text prediction, or sentiment analysis. It might take quite a lot. So with Keras NLP coming in, it comes in as the modular library version of Keras, right? So it extends from the Keras framework. That means that you get all the full capabilities that also have or are also within Keras. So you still get it with Keras NLP. That's one thing to note. And that then tells you that you also get the full blown capabilities of also the TensorFlow ecosystem. So that's also one thing that comes as a plus when you're using Keras NLP. So just a focus on this word modular building blocks. If you remember back in school, what we mean by modular building or modular software design, basically that means that you're able to separate different functionalities when you're writing your source code. This helps you debug one easily, and then it makes your code way cleaner and easier to actually reuse. And it also eases for collaboration because, again, that modular version, you only need to execute a certain piece of code to perform a specific functionality, right? So modular design is one big aspect of Keras NLP. And then also just looking at what it offers, we have tokenizers, which are pre-trained. You can also create your own tokenization, model building blocks, matrices that you can use to measure the performance, text generation utilities, as I've just mentioned, and then definitely pre-trained models also exist. We'll get to interact with some in just a few. So yeah, basically that's a swifty introduction of what Keras NLP is. You just need to know it's the extension of Keras as a framework, but now the natural language processing aspect of it. So it came into light about 2021 thereabout, or was it last year? So when it comes to the Keras NLP, there's quite limited information out there. So that tells you that you as the SSA community, there's quite a lot that you need to do in terms of contributing to the Keras NLP community, right? So test it out after this, see what it can do, what it can't do, see the bugs, raise them on the GitHub official page of Keras, the issue, raise an issue on there and have the Google team look into it so that we can make Keras a bit better. So yeah, the ease of usage is also still there when it comes to Keras NLP, and you'll see how small piece of code will be able to do quite a lot. If you've been in the natural language processing space for some time, then you'll realize that Keras NLP quite summarizes quite a lot, right? Especially this aspect of tokenization or pre-processing, which is attached to the model when you're actually initializing it. So we'll see how that actually works. So just a deeper dive into Keras NLP and how it works and what it is. So one thing about Keras NLP that I would like to have you note is the fact that is this statement. If there's one thing you'll take from it, is that it has progressive disclosure of complexity. And I think when I first had the YouTube videos or the tutorials from the official team at Google, this was the one thing that was able to take in, that it has progressive disclosure of complexity. So that means that if something is complex, then it should be possibly done within Keras, right? And if it's a simple task, then it should be simple. You'll find that in NLP, especially simple tasks, sometimes they are made way too complex to even comprehend. But when it comes to Keras, it has progressive disclosure of complexity. So if it's simple, it's simple. If it's complicated, then it has to be achieved and to be done, right? So it's possible on there. So for example, here we'll interact with what we call a BAT classifier. BAT is also a baby of, or a fruit of Google, right? By Google researchers. Yeah, it should be by Google researchers also. But I think not officially by Google, but from the researchers. And then so BAT classifier, we'll see a constructor called from present, and then we'll see what BAT preprocessor is. And again, they all have an attached from present constructor, and we'll get to see the importance of this. Then the BAT backbone, the BAT tokenizer. Hopefully there's a bit of understanding in terms of what we mean by tokenizer, but just in case not, I'll just explain as we go. All right, so let's have a look at this given item here, tokenizer, right? So the Keras tokenizer, the Keras NLP tokenizer, basically, as I mentioned, human language, computer language, they're two different apples and mangoes. So for us to actually convert the human language into something that the computer can understand, then we use what we call a tokenizer, right? So a tokenizer basically, as you can see here on the GIF, the GIF that's running, is when you have a sentence, for example, or you have human text, XYZ. So each word is going to be allocated a certain number, a numerical number. This way you've converted from human language into a numerical number, right? And it makes it easier now for computers to understand because of the numerical nature of computers. So to actually call a tokenizer, this is usually one of the first steps, is tokenizing your data, right? So if you have a set of maybe reviews, you have to tokenize that data set. So the first thing you do is just call Keras NLP.models and then pass in which tokenizer. For example, here we'd work with the BAT tokenizer, and then pass in which language or which what do we call them? There's a word for this, of which I kind of, the word kind of ran away from my mind, but if I remember it will continue. I'll mention it. Then pass which model that you want to use, and that way it's good to go. All you need to do next is just compile, fit, and then reuse. Then the second aspect is pre-processing. So basically, this converts a string to a dictionary of pre-processed tenses to be consumed by the backbone of the model. So, for example, the first thing, you turn it into a string. You turn it into row bytes of strings. Token IDs. So the tokenizer give different tokens, this time in form of numerics. And then this now takes this string dictionaries into tensors to be consumed by the backbone of your model. And then how to call that, basically the same thing, still within the keras.nlp.models, then xx preprocessor, which preprocessor are you going to be utilizing based on the model that you actually have. All right, so yeah, and then finally the backbone. So this basically converts pre-processed tensors to dense features. This happens just right before you pass it into a task. The word task is what I was looking for, and then converts, and then calling this again is just keras_nlp.models. The name of your model, then the backbone class. Then finally, the task. So when it comes to a task, this is basically now a model that combines the pre-processed, the string pre-processing and the model. Then what you have as a result is a task. The same way when you combine data and a machine learning algorithm, what you have as a result is a model. So in this case, when you combine a string pre-processing and a backbone, you end up with a task. And tasks come up with specific layers to solve certain problems. So we'll use various tasks that we're going to be specifying to perform text generation, sentence classification, either sentiment analysis. So was it a positive or negative, for example, that. So in this case, we can see you have a BAT classifier, right? So that's your task right there. You can have a Robata classifier, a task, a Robata, a BAT classifier, whichever model that you select to use, you find a task on there. So there is a list of all the tasks that you can find, which I'll show you later on, that are present within Keras and utilized by Keras. And then finally, there's also the Keras NLP aspect, where you have the text generation, right? And it utilizes large language models such as the GPT-2 or OPT, for example. So all you need to do is call in your task again that is supposed to do that. And then basically here your task is the GPT-2 casual. It should be casual large model, and then just from present, this way it comes in, as you'll see, it will be already pre-processed. The pre-processing aspect will already be attached to the task itself, as we have mentioned on here. And all you need to do is just next, you just fine tune it, compile and fit, then you predict. Yeah, so we'll come back to this in a bit on how this works. Just to take this for a spin on how this actually works or looks like. I'm hoping my screen should still be visible. You should be seeing the because I shared my entire screen. You should be seeing the collab, right? At this point. So basically, Colab is also part of the Google ecosystem, as you might know. your collaboratory notebook that is found seated within the Google Cloud, and it facilitates for that. So the first thing, or the first drill that you should be having, is definitely installing your libraries, right? So you install if they do not you do not have them there yet. And I have my outputs already generated just to kind of save on time, right? And we'll just see roughly on a rough basis how actually it works in real life, how Keras NLP works. So the first thing you're supposed to do is definitely install it. So Keras hyphen NLP, then upgrading it in case you have an outdated one. At this point, I think we are looking at the version 0 point something, 0.06, 0.60, sorry. So yeah, this should be it. It's actually 6.1. So that's what we have. Your requirement has been satisfied if you've already downloaded it. Then just for the sake of acquiring a data set. So then the next thing is definitely importing it, right? So you import your Keras. Then the next thing, we're going to find a data set. And I called on TensorFlow data sets, same as Seaborn data sets. If you've worked with Seaborn before, they're basically data sets within the given framework that are there for you as a developer to play around with or to play on with, right? So the first thing is you get the data set. So I'm going to split it into two, as usual, your train set and your test set, right? So for if you actually do not understand this, is for just to, I usually give the example of doing an exam, right? So if you're doing an examination, if you're being tested, you're given an exam paper first where you have to fill in your answers, and you're not being given the exam sheet and the marking scheme, right? So same case here. The person we're trying to see if they can perform well is our model, right? In this case, we'll be using the BAT classifier. So we want to see how BAT, the instance of BAT that you're going to be calling to classify our data or our sentences, has performed well, right? So we're going to train it first, the same way your teacher teaches you A to Z, and then they give you an exam, right? So that's training you, and then they test, they give you the test aspect, and then you can be able to see if it's actually worked or not worked, right? So the information is being given to you, and then you get the test aspect, where you get to fill in the exams. So we divide this into the train and the test data. So TFS, DS, this is how I imported it. This is basically the alias. Then we're going to load in our IMDb. IMDb reviews is a well-known data set, right? That contains the reviews of different movies within that have been done in the US mostly. It's usually mostly the United States, right? Then splitting this is basically just splitting the test, the data itself. And the first aspect will be stored, which is the train that we've stored on here, will be stored in this variable here, the variable at the first point, and then the test will be stored at the second point on here. And then also defining your batch size. Basically, batch sizes is how much is going to be loaded in. And then at this point on here, now we get to the good part. Let me just zoom in a bit. So we're going to create, and you're going to see how easy this is. We're going to create an instance of the task BAT classifier, right? So in this case, we're going to call Keras NLP.models and then .BAT classifier. From present is our constructor, right? And then the BAT base in English. So this basically means that this BAT classifier that we're specifying on here, so this was essentially trained on English data. You can come at this point to actually see what this actually means. So I'm hoping again you can still see the screen. When you look for the Keras NLP, then /models, it will show you all the models that are there. and what data has been used to pre-train it. And you can just basically look for more information to find the perfect fit to work with the data set that you have. In our case, since it's US data, right? It's US movies and mostly US reviews that are in the IMDb database, the English version of it. So that's what, hence we're using that task. All right, then the next thing that I am going to do is definitely just fit this into your classifier, right? Then after you fit in your train data set, right? And then now you get to see, you also pass in your validation data. So you can have you usually have either your train, your validation data set, and also finally your test data set, right? So validation is just that beef up to confirm that, yeah, your model is actually performing the way it's actually performing, just as the name states, a validation data set. Then the next thing we're going to do is passing in the instance, predicting now what you have of the sentences that you'd like to see or to predict to see if it's actually positive or negative. So in this case, the first sentence is, what an amazing movie. And then the second sentence is a total waste of my time, right? So let's assume these are some of the reviews that have been passed on. For example, you watched Oppenheimer, you watched Barbie, and you have a review for it. You can come put it here and then we see what it's going to predict. So on here, what an amazing movie. We want to see what our model is going to say about this. What sentiment does it feel about this movie, right? And then about this review, sorry. And then what sentiment does it also feel about the second item, right? So at this point, the next thing should be your output after you've trained. It should give you the positivity on the negativity array of each sentence. So in this case, so whatever you have here at the first point is how negative, towards how negative that movie is. Let me just show you a bit more. This was a really large data, but let's try and look at a clearer one for the purpose of understanding this. So what you get is an array, right? A 2D array giving you the first aspect. Let's say, for example, we see that this the negativity has been ranked as 0.004. That's the probability that this review is actually negative, and then this is a probability that it's actually positive, right? So most of the time, if you actually do and train your model well, you might get completely distinctive values, which is a bit easier to interpret. And sometimes it might require you to actually put a threshold, right? So maybe you say, for us as a company, positivity starts from 0.7. That is our target, for us to have 0.7 positivity, the probability of positivity to be start from 0.7. Then the rest of that would be negative. And then the second sentence, we can see in terms of the negativity, it's ranking closer to 1, right? Probability is 1 to 0, mathematics. So closer to 1, that makes it slightly way more towards the negative aspect, and then this one is towards the positive aspect, is less likely to be positive, right? So that gives you, this was still a different model, but to the same sentences, and that's the output that it gave. That was just for the purpose of explaining that it could be very distinct. So it's either positive or negative, getting to have Keras do that for you. And then the second or the final aspect is trying to play around with the text generation and seeing how it actually performs. So in this case, I did not fine tune mine, right? So I didn't actually fine tune mine. For example, in this case on here, we did fine tune our model based on the IMDb data set. You can fine tune it based on the topic that you want your model to learn or train from, right? Because remember, these are pre-trained items. So they've essentially been pre-trained on another data set. And then to fine tune it to your specific use case, you can use sample data sets that are relevant to your use case to kind of fine tune it and make it a bit better and improve on how it's going to perform. So in this case, I just called the GPT-2 causal large language model. And then from presets, so the preset again, still the constructor here, and then on here you come in, that's your task, and then on here you come in and probably pass in the dot generate, since we've created our instance and stored it at this point, right? So our instance is stored within this point on here. If I scroll like this, yeah, it should be better here. So your instance of your generator model has been stored on here, or of your GPT-2 has been stored at that point. And how generator models work basically is that the rules, especially in this case, the GPT-2, right? So how they basically work is, how do I explain it? Is that they basically take tokens that have been fed about another information, right? So it predicts each token or an input sequence given all the preceding tokens, right? So you basically get to have, for example, a user prompt, and then it can be able to generate text, something that makes sense based on the user prompt to predict what the person was going to say, for example, right? Like the good example of using your emails or Gmail, right? Hello, it's already picked up the name of the person on there, or maybe you're typing, how are you? It's already completed for you this morning, or maybe today, or maybe how are you? And then it completes doing, right? So it tries to predict based on the user prompt. And this usually has a name, and I think it's called canonical approach, where it takes kind of it's able to predict the tokens and the sequence length based on the presiding or the predecessing tokens that have been used on the model. So on here, what we're going to do, we're going to pass in, for example, this part on here, right? So my trip to Yosemite was, and then maximum length, this is basically just a parameter associated to the generate function that is found within the GPT-2 LM task. So you pass in the maximum length of text that you want in return, right? See the way ChatGPT can give you a whole response, or BARD can give you a whole paragraph response. So you can actually limit this with maximum length if you're building something on your own. And this is what it gave, right? Because it was 200, and this is what it gave. So was from this point, all this has been predicted by the model or the instance that we have just built. So the process, the best I've been in, and then my first experience, all this is what it's predicted. So hopefully you've gotten a feel of that. And as I mentioned, you can see we're not doing any tokenization. We're just fitting in the data to our instance directly. Why? Because it's already a task. Where we've said a task has the what we call it, has the pre-processing aspect, the tokenization aspect, and the model itself, right? And the pre-trained model itself. And then you just get to feed in your data and then compile, fit, and predict, right? You see how simple that is. But also, as we said, progressive disclosure of complexity. In some cases, this might not be super helpful. For example, let's say, for example, you have maybe shorter sentences that you need to probably, let's say, to process, right? Then in this case, this might not be super helpful. You might need to go in depth and call in the classes that we have just seen at this point, and we'll see an example of that to kind of just customize your pre-processing process, right? To be able to kind of get there. So another example I'll give is after working with the IMDb data. So another trial that you're going to run is using Kaggle data. So in this point, again, Kaggle is a product of Google, where I think a couple of you, most of you, or almost all of you might already know Kaggle, where it's a community where developers come to engage in competitions and industries get to post challenges. So a lot of money is made on this site, right? So if you're a broke student, come here, do a competition, tune a model, and then see if you're going to get some luck, right? So this is a data set that I want us to work with. And the company that contributed is Quora. In case you don't know Quora, this is it. It's basically a social media platform where people just ask questions and then people answer, right? So if I post a question, for example, she said, what are some dark truth that has made you stronger, right? And then people just come here, interact with that statement, upvote it, downvote it, and so on. So here is where we get the comments, for example, right? So that just for you to get a feel of how Quora looks like. So in this case, what Quora wanted the Kaggle community to do, that's you, myself, and every other person who's into ML and data, is to basically predict whether a question asked on Quora is sincere or not, so if it's insincere or if it's sincere, right? So that's the first aspect. Then the second aspect is because you already get a data set that you need to fine tune your model into learning, right? So remember, the models are already pre-built, right? Or already pre-trained on other large data sets and gigabytes of data sets. But we need to fine tune it for it to be able to understand our use case. And Quora has provided that data. But in terms of this, what did they use to classify something as an insecure statement or a secure statement? So we can see here it was either something has a neutral tone, right? And is rhetorical and meant to imply a statement about a group of people, right? So a group of people, maybe we segregate, for example, Rwanda, and we say maybe a stereotype of Rwanda, they are very tall, for example, right? And maybe frame the question, are Rwandese tall? For example, that. So that means our model should read that statement as an insincere question, right? And then we have our trained set, our test set. I've already explained that. And then embeddings, if you're not familiar with the term, an embedding is basically a vector representation of something, right? So converting, if it's a word, you give it a vector representation. That's what we mean by embeddings. And then these are the columns in our data set that we're going to see. So hopefully you've gotten a feel of that background and what we are trying to do. So let's try and see what Keras NLP can do for us in this case, right? So we pip install. This is a new notebook. So I just installed it and requirement has been satisfied. Again, I just ran the items because of time. And the next thing, as we've said, the next drill, import all the libraries that you need. Then the next thing we're going to do is load the data directly from Kaggle, right? And that's the data set that I've just shown you. And then the next thing is we're going to read, as you can see here, it told us that it has saved this into the train.csv, right? Because that's what we were reading, right? So after we call in the Keras NLP data, then the
Hi
train.csv.
there.
Yes, hi.
Sorry to interrupt. You are running out of time, and
Okay,
maybe you could.
okay. Okay, cool. So this given that pd dot read, we read the item and this is what we get, right? The QID, as the site said, the question text, the target. So for example, just to get a feel of that, we get to see this question here has been assigned 0. That means it's a none. It's a sincere question, and if it's 1, then that means it's an insincere question. So hopefully, yeah. So for example, here we can see the mention of blacks, the mention of that of a certain gender, people who identify as a certain gender, being classified as insincere. Yeah, and then the next thing we're going to do is having our text into a list, and then our target also into a list, storing them into different places, into different variables. Then on here, the next thing that we're going to do is running the classifier, right? So the same drill. So we just basically call Robata. In this case, we're using Robata. Then pass in the classes that you want predicted. Then we're going to put the backbone as false because we don't want it to retrain the backbone again. We just want it to fit directly. When we fit, we get our instance here, model, and then we can use that to actually predict about another sentence, right? So the same thing. Then finally, just one more thing in terms of custom pre-processing is basically you have your tokenizer on here and you're trying to actually customize it, right? So what you do is basically you have to now call the tokenizer from Robata, right? Remember the last time we just called the task directly, then specify your tokenizer variables, and this way you basically just fit it again, right? If you want to maybe specify, maybe if it's the sequence length or the number of tokens, you can do that using the tokenizer. Then again, pass this inside your classifier, in this case, an instance of your Robata class, and then you're able to predict. And basically, that's how you'd actually customize in terms of pre-processing. So yeah, I'm guessing that would be it in terms of customization. And the maps to that is basically these are the resources. And yeah, thank you. Sorry for spilling over. I hope I didn't spill much.
Uh, Thank you very much, Diana. That was a very informative session.
Yeah.
I'm sure everyone enjoyed it. That was quite insightful. Thank you very much for that. For folks like me that had baptism by fire coming into NLP and AI, generally, TensorFlow, especially TensorFlow 1, was hard. Was not an easy one, right? So Keras really brought
Yeah.
in that flow of getting things going. So thank you for that. Thank
Yeah.
you for that. I'm sure a lot of people have learned a lot today. By the way,
Yeah.
to introduce Diana, she's an associate data scientist, right, at Roche. Is that properly pronounced? Roche, right? And
It's
she has
Roche. Yeah.
Roche. Oh, I thought it's the French Roche. Uh, so she has worked in health, and NLP is the branch of AI that is in charge of how computers communicate, right? Computers basically only
Yeah.
understand the that once. You have to make them speak the words, and you have to teach them how
Yeah.
to. So thank you again. But thank you for that. Before we go on our next session, I'd like to know where some of our folks are from. I see Mauritius, I see South Africa. Please put this in the comment. Let's see, where are you from? What country are you joining us from right now? Let's have it. Oh, South Africa, GRC. Yeah, amazing. Uganda. Thank you for that. Oh, Sub-Saharan Africa, Kenya. Oh, well, we're represented everywhere. So also, thanks, GDG Calabar. Yeah, would you like to tell us the chapter of GDG you're also, reaching us from? CMU Africa. Oh, Rwanda. Whoa, we have people from all over the place. That's amazing. Thank you, thanks everyone. So our next session will be uh, by Marvin Ngesa, and we'll be talking about Keras for curious and creative. As someone that makes use of Keras quite often, I know very well that Keras it helps with a lot of getting things done really fast prototyping and all. Ngesa is an engineering manager. He's a machine learning engineer specializing in signals and image processing, right? Computer vision, and specifically in computer vision, right? He started cloud ML engineering as an Intel AI innovator, and joined Liquid Telecom as an IoT solutions engineer. Interesting. As an Intel AI innovator.
Are you speaking? Hello, Stu.
Hey, Marvin, are you there?
Yes, I'm there. Can you hear me?
Yes, I can hear you clearly. Yeah,
Perfect.
lately Marvin has been working on sensory data analysis for IoT devices to help manage device life cycles and drive the right consumer experience. He founded Nairobi AI, amazing, and leads machine learning efforts in communities such as GDG Nairobi and Tani ML Kenya. Everyone, please join me in and welcome Ngesa Marvin. Please, you have the stage, Marvin.
All right. Thank you for the introductions. And it's exciting to see all of you join this call. I can see some guys are joining from DRC, some guys from South Africa, guys from Rwanda. Thank you so much for joining. My name is Ngesa Marvin. And today I'll be talking about the blocks that you see behind me. I'll be talking about how you can build a foundation. And then once you have a foundation, you can lay blocks on top of that foundation in a sequential manner. And then in between, you can also have like something like a mortar or a glue that attaches all these blocks. And then relates this analogy to Keras. So welcome to the session. And this session is going to cover content from the guys who are at beginner level and then go all the way to intermediate level. And that means that I'm going to take you through like what I do day to day from devices and how devices collect different types of data, from structured data and unstructured data, like images and videos, and then tell you how probably these devices understand this data, particularly the ones for images. And then we'll go into how Keras can help us to understand these images and why we need to use tools like Keras. And then we'll go into a new exciting topic in generative AI called stable diffusion. So day to day, I work for a company called Safaricom, and I'm responsible for the devices that they use in their new emerging areas like Internet of Things and cybersecurity. And these devices collect a range of data. Some of them are structured, others are unstructured. The ones that are structured, like the ones you see on the left, can collect things like the consumption data from a water meter, or consumption data from electricity meter, or even vibration data from a generator. But we also have other devices like cameras that can collect unstructured data like images and videos from it. And these devices can collect all this data, but sometimes they don't understand what's in the data. They, like ourselves, we can be able to see the environment, collect the feeds, and we can interpret what we see in the environment. But these devices, they can collect what they see from the environment. Let's say you are in the streets of Lagos somewhere, you can have a camera that collects information from the environment, but it won't tell you if someone is being mugged. But is there a way that we can make all these devices to be able to see the environment? So the different ways in which you can collect data from the environment. For example, this is a Kenyan-made dev kit that has a range of sensors like temperature, humidity, and it also has the ability to communicate this data to the cloud. And there are different ways in which you can represent this data. You can see, for example, you can have like 51 representing 21 degrees. This 5A is in hexadecimal. And you can also have a binary representation of it, but you can also see that at the 10th and 11th bytes, 10th, 11th, and 12th bytes, you can be able to see the temperature and humidity from this particular device. And 21, of course, is like a structured data, especially if you have it in a table, in, let's say, an Excel sheet. You'll be having like structured data that you can easily use for machine learning. But what about images? How does a computer understand images? How does this devices understand images? Is there a way in which they can be able to uniquely understand these images to a point where they can even recognize what's in the image? And I also know that this is a developer talk, and I don't need to talk much. I need to show you some code. We are developers, and we need to see some code. So let me quickly change my screen and probably show you how a computer can understand images. Let me know if you can see my screen. Okay. Okay. Can you? Let me just double check. Yes, you can see. All right, okay. So images are just numbers, and you can find ways in which you can represent the data in an image as a matrix of numbers. And the range of libraries that you can use to be able to, let's say, load an image, then get details from an image. For example, here you can see that I have, first of all, I have all these libraries from NumPy to Matplotlib to help me visualize my image, to tabulate. I want to convert what I'm having in my image into a table. And then I also want to access, of course, the image from some point. So I'm going to use the pillar library. And I'd also want to apply some filters in my image. So this is just a general way of doing it. Then I'll show you how to do it with Keras. And the first thing I'm going to do is to specify a path where I can get my image. But first of all, let me show you where my image is. Where is it? I think it's here. So I have this image here, this one and this one. And if I open it and check on the properties, go here, properties, you can see it's a 1280 by 1280 pixel image. So if I go back here, I can load it and then check on the width and height of the image and confirm that what I'm having here in the screen is actually what I've uploaded from the computer. And of course, I specify the path, use the pillar library to load my image. Then I can show it the way you see on the screen. Then I can also check on the width and height of it, then display the pixels. So what I'm showing you here is exactly what I've got from the laptop. And then this image is 1280 by 1280, but I want to display this. I want to have like rows and columns, or I want to have a matrix of this image into my slides. And having a table with 28 rows and 28 columns, I think it's big. It will be huge in size. So I want to resize it into a 6x6 matrix and then put it on my slide as a matrix and then as a table. And I'm going to go here, do the resizing of the image. Then I can show you what I have after resizing, which is this one. So from this point, 1280 by 1280 to this one, which is 6x6. And then I can convert what I'm getting from it into a table like this one. And ideally, an image usually has pixels on it. And you can think about pixels as dots in an image, where every single dot represents the intensity of the lightness or darkness in that particular dot, where 0 is darkness, and then 255 is the white part of it. And then depending on the intensity of the color that you have, if it's a grayscale image, you can have a number at that particular point. For example, you can see here that we have something that's white, white, white up to this very end. If I go to my photo, you can see that at the top it's white, white, white up to almost up to the very end, similar to this one. But at the bottom, you could see like a lot of darkness. So you could probably find numbers that are close to 0. So if I check on it, you could see that I have those numbers that are close to, that are going closer to 0 from 255. And from that point, you can see that indeed images are just a matrix of numbers. So back to my slides, go here, share screen. Okay. Should bring it in a few. Okay, I think I have it. Let me know. I hope I'll be seeing the full screen. Okay. Let's double check if it's full screen. I believe it's full screen. Anyway, you've seen that images are just numbers. So from this 2180 by 2180 image, I've resized it into 6 by 6 matrix, and then I've converted the matrix into, I've converted those pixels into matrix, and then I've displayed them on a table. And there are also a bunch of things you can do to an image. You can be able to do a range of, how do I put it? A range of filters on the image, and be able to do a range of things like make it blurrier, or detect some edges from it, or just make it give you some unique features from it. And from this point, you can see that you can have a data representation of our image. Of course, you're using linear algebra, but don't really worry about this. There's a way that Keras makes your life easier without worrying about the mathematics. But of course, linear algebra allows us to represent the data from an image in a particular form. And you can also decide to change the matrix into vectors, because when you're building our model, there's a way that we'd want our layers to accept what we're giving it to it. Maybe our layers will not want to accept matrices, but they want to accept vectors. So we may want to multiply 28 by 28 to get 784, so that we have a vector that we can feed into our model. But ideally, you can think of deep learning as a matrix manipulation. And by matrix manipulation, ideally, I mean you are always trying to approximate y as a function of x. So you have input, like the vectors that I've showed you, and then these vectors, of course, you can multiply them with, let's say, filters or a bunch of weights, and you're always trying to adjust weights and biases. But at the end of it, you're trying to approximate y as a function of x, and that's what deep learning is. But also here, you can see that there's some unique things in it. You can see that there's something here. Let me just pick a pen so that I can point it. You can see there's an activation function here, and there's a bias here. And probably you're wondering, why am I having this one here together with this one? Because in linear algebra, I'm used to y is equal to mx, let's say, plus c. Why am I having this extra one? This extra one is just an activation function. And by activation function, I mean you're trying to add non-linearity properties to your equation, because life is not usually linear, and probably you'd want to model data that are distributed in a nonlinear manner, and therefore you need to have an activation function like this one. And then you also need to add like a bias that could help you to reduce overfitting and even improve the performance of your neural network. And this is what you can say it's a neuron. And you also have the activation function. I've talked about how to flatten what you're getting. For example, here you can see that you have images, about 100 images, and then they're all 28 by 28 pixels, and you're converting them into vectors. That's 784. And I've told you that when you're building our model, we'll have different layers. And these different layers, for example, case in point dense layer, they have a limitation in the sense that they don't take matrices. They don't take in matrices as an input. And therefore, you'll need to convert all these matrices into vectors, and then feed the vectors into the dense layer. So that's why you're flattening it to 784. And then after that, of course, you need to make a guess and then see if a guess makes sense. So make a guess, or rather make a prediction. Then once you make a prediction, you're going to check how accurate your prediction is. And once you've checked that, you're going to calculate the loss that you're having, and then maybe you can try to find ways to reduce this loss. And one of the ways to do this is by having a curve like this of loss against weights. And your role is to find the best weights that gives you the least loss. Then once you have that, you're going to have it into the equation, and then it's going to make the equation become a good model compared to the first one that you had. Of course, here there's a bunch of calculus, things like, how do I call it? Differentiation. So you're going to have chain rule and differentiation, then go on the negative side of the gradient, and then go until you can reach the minimum point. Sometimes it's very hard to reach the minimum point, but your goal is to get the best weight that gives you the least loss you can get. And then you iterate it over and over again until you have a good model from it. And generally, that's what deep learning is. It's just matrix manipulation, trying to fit y as a function of x and adjusting all the weights and biases to ensure that you have a good equation. All you're trying to do is find the best distribution or equation that fits the data that you're trying to give it. But I know some of you are from machine learning and are wondering, okay, now what's the difference between what you're showing us and what we've been having in machine learning? The difference is just that in machine learning, you have almost similar steps. Of course, you define the problem, you collect the data, you extract features, you train a model, and even do evaluation. But in deep learning, the difference is that these features can be so complex to a point where you need some kind of tools to help you extract the features. You need tools like convolutions to help you extract the features. So instead of doing feature engineering on your own, you're going to have tools like convolution to help you do feature extraction, and neural network learn these features automatically. And those are the key building blocks of deep learning, all the deep learning ingredients, from data sets to models, layers, activation functions. I've talked about it. I've talked about cost and optimization as well. And all this, if you check on it, it involves linear algebra. Of course, you want to have your answers in probabilities. You also have calculus when you're doing optimization for this entire thing. I mean, it involves a lot of mathematics and all that. And I know you guys are smart, but sometimes you may have millions and millions of parameters to a point where maybe it's good to get a tool or a library that helps you simplify all this entire thing. And this is where Keras comes in. And Keras helps you to, or Keras' mission statement is to give you an unfair advantage, or give any developer an unfair advantage, especially the people who want to ship apps. And therefore, you don't need to create an entire machine learning architecture from scratch. And Keras focuses on debugging speed, code elegance, maintainability, deployability, and also it helps you to have a smaller code base that's also readable and that you can easily iterate. And you can now use Keras to, probably I could just show you one thing in my code if I get back here. Okay. In the screen. Wow, I hope I was sharing my screen. I can't see my screen here. Okay. Entire window. Go here. Okay. All right. So once you have all these matrices, I talked about the filters. Where is it? I can't see it. Okay. You can have a range of filters, which does really amazing stuff. And in case you are a beginner into all this, don't worry about things like Laplacian or whatever. They're just nice tools that allow you to be able to extract unique features from an image. But I know most of you have been using things like Snapchat, and you've been trying to use filters in your images. Ideally, what you're trying to do is have some matrix that runs on top of your image and do some changes to it. Like, for example, if I have that original image of mine, I can run this. Where's the filter? I can run this matrix on top of my image. It's called a Laplacian filter, and then be able to have something like this. But this one is on the 6x6 image. But let me do it on the 12x80 pixel image so that you see the output that you have from it. So I'm having a range of filters: the horizontal one, the vertical filter, this one for edge detection. I also have another one called Laplacian for edge detection, another one for Sobel. I have one for Gaussian to blur your image. And please take note of this thing called Gaussian blur, because in the upcoming sessions, I'm going to show you how to add Gaussian noise into a photo and do amazing things with it. So if I go down here, of course, I load the same image that I'm having. And then I can have my original image, then add some noise to it, this Gaussian blur. I can also decide to detect some edges from my photo, remove every single thing in my photo, just give me the edges. I want to then detect edges from the photo. You have them there. Or I want to have brightness on my photo. There's a way that I want to detect, let's say, a Sobel edge detection. There it is. and a range of them. Okay, I hope you can see my slides. And at this point, ideally what I've been showing you is having an input image. You can see that this is my photo, the one I've been showing you, and I have them in a table format, and I also have a kernel here, or a filter, and it's a 3x3 filter. And what I'm trying to do is I want to detect information from this 239 part of my photo. So what I'll do is I'll center my filter at 239 and then run it on top of it. And what I'll be doing is a bitwise multiplication, 1 by 255, 2 by 255, 1 by 255, and then do the summation. Then I'll have this number here. And Keras also give you like a nice tool to do the same thing that this thing is doing at this point. That this thing is doing at this particular point. And then once I've done that, I'll translate them to this new convoluted image, the same way you can see it on the screen. And I may have lots and lots of images, and I would want to like reduce the size of this image, but retain the most important information in my image. And therefore, I could try and use something called an image grid. It's almost similar to a filter again, which could have, let's say, a 2x2 size, and then move them with 2 strides. So what I'll be doing is that I'll come to this particular point, and when I'm here, I'll check the maximum number. I mean the number with the highest value, then translate it to the next layer. Ideally, what I'm trying to do is that I'm trying to check the most important features in my image. Then once I have them, I move them to the next layers. And you can see how I'm doing them with Keras at a particular point. But ideally, what you're trying to do is you're trying to reduce the size of all these images, because you're going to have a lot of images, but enhance the features that you're having. And then I told you that life is not linear, and you may want to extract some complex information from this image, and therefore you may want to add nonlinearity to it with softmax function or ReLU, a range of activation functions. But you can choose the one that works best for you, depending on the use case that you're having. And in this particular use case, ReLU works best for me here. So you can see here I could have like an input feature map, and then I apply this ReLU. Then I have this one, and you can see that this one here doesn't have all this darkness. It doesn't have as much darkness as this one. This one doesn't have as much darkness as this one because I've applied this rectified linear units. All right, so those are ideally the 2 steps of convolution neural network, or applying a convolution to a neural network. It involves 1, doing the convolution, having your input image, and then this side having a filter. Then the filter runs on top of the input image, collecting the most important feature. And they may start by collecting things as simple as edges in the first layers. And then as you go to more layers, you're going to find that you're not just detecting edges, but you're detecting shapes. And as you go deeper into more layers, you reach a point where you're not detecting shapes. Let's say it was my face. You'll start to identify nose, ears, eyes, just by having all these filters. And then that's just one step of this convolution. And that first step involves, this convolution neural networks. And that first step involves convolution, nonlinearity, and pooling. And I've explained to you why you do all these 3. But ideally, what it helps you is to do the feature extraction or the feature learning from your image. Then the next part, you're going to do the tasks that you want to do. Do you want to do, let's say, object detection, classification, or object detection, or segmentation? And then always you can use this first part, and then what you do is just change this later part of it. So first part for feature extraction, but the second part for the tasks that you want to achieve, be it classification, be it object detection, be it segmentation, or even probabilistic control. And this is how it looks in code, where you can have, let's say, a convolution layer with 32 filters. I've just shown you a few filters, but imagine having 32 filters at the same time. Then you have a filter size, and then you have an activation function, the rectified linear unit, because you want to learn some complex things in your data. You want to map some complex things in your data, because some of these distributions, they're not linear. Then, of course, you can also want to reduce the dimensionality of what you're having, but maintain the key important features in the image, or enhance the key important features in the image. So you'll do max pooling, and then you can go to a second one where you even have more filters compared to the one that you had initially. So like this one, you have like 64 of them. Then, of course, now you'll feed it into the second part of it. So we're done with the first part for feature extraction. Then you go to the second part where we're doing the task, the computer vision task that we need to do. Yeah, and you can think of Keras as as something that give you the building blocks that you can use to build a house. When I was starting this session, I showed you some blocks behind me. I think they're still there. They're not real blocks, but Keras can give you blocks that you can use to build your house. And these building blocks can be very consistent and simple. They can be consistent and simple APIs that Keras give you. For example, if you want to get into a door, then Keras give you things like data loaders that will have like a provision for that. And you can decide to divide these blocks, or rather these blocks include things like the necessary imports, the data pipeline, the model construction, the model compilation, model training, model inferencing, a range of them. But let me break them down, then go to them step by step. The first one is the necessary imports. You guys have been working with Python. This part doesn't necessarily need much explanation. You know it already. But ideally, we're just trying to import the necessary packages, Keras and TensorFlow. But take note that today we have something called Keras Core. And as we also head towards Keras 3.0, we may have different ways of importing Keras. So this one is just I will say the old version of Keras, but in the new one that's coming, or that we are just about to have, allow you to import Keras in a different way. And the next one is a data loader. And in our house analogy, I told you that behind me we have a foundation, and then we have a block, and Keras gives you the different blocks that you need to build a house with. And then you'll also have like a mortar that you can have between the bricks. That's the activation function. These blocks could be the different layers. And then I'll show you what the foundation is. But first of all, let's upload our data. We can have a data loader. And then this data loader will help us to shuffle the data, mix them, then neatly package them into different groups. And then probably also you may have some specific operations that can be applied to them through the map function. And then now at this particular point, we may have something called a sequential layer. And you can think of a sequential layer as the foundation or the base plate of the building block that you're having. Or you could think of it as a container that's going to have all your layers neatly arranged on them in a particular sequence. But let's go back to our house analogy. Think of it as a foundation that you're going to have. And after this foundation, you're going to layer your blocks neatly on top of it, one by one, in a particular order, let's say sequential order. And then in between, you're going to have a mortar or a glue that attach them together. And you can see that the activation function. So that's the sequential layer. And then, of course, you're going to also have compile, where you're going to check on the errors from your equation, then find ways to reduce the errors using the optimizer, and generally check the quality of your model that you're building. Then you fit it. This one in a bunch of epochs, and then after that you're going to try to make predictions. But Keras give you all those tools that you can use for that. And then you can do a range of tasks with Keras. One of them is classification. Let me just walk you through a notebook here that can show you classification with Keras. Okay, 23. I think I'm still on time. Share my screen. Window. Let me share the entire screen. Okay. So I have this notebook here, but I don't want to walk you through the notebook one by one. I believe it's something that you can be able to read. In fact, let me just drop it here for you guys. Wow. I think I can't join the chat. I'll drop it later. I'll drop it after this session. But I'm just going to show you like the key things that I've talked about in my slides, and then you're going to run this on your own to just get the concepts. But these are a beginner or basic kind of tutorial for classifying images of plots in Keras. And of course, the first thing is you upload the libraries, the dataset is there. Of course, I want to walk you through this, but I just want to show you the key things in this that I've talked about in my slides. One of them being the model, or one of them being the block that's behind me. I told you that this talk is about these blocks that you see behind me. And I've also showed you that the first thing that Keras give you is the sequential model. And this sequential model is like the foundation of our house. And then on top of this foundation, we're going to have blocks on top of each block in a particular order. And these blocks include the dense layers. And in the dense layer, for example, in this line, you can see that you have a dense layer with 128 things, and then you have an activation for it. So this activation could be the mortar in between the blocks. And then this dense basically means it's a fully connected layer. That means every block on top of it is connected to every block before it. Or, yeah, you could just take it like that. So this is it, but I'll share this so that you can go through it and just check how you can be able to have a data set, train your network, and use Keras to optimize the network, and even classify things from a data set. Okay, back to my slides. I think I'm still on time. Main, go here. Okay. All right. So I'm now going to go into Keras philosophy, and the creator of Keras want Keras to be flexible, simple, flexible, and powerful, in the sense that they want you to have things like Keras sequential API that can be beginner friendly and anyone can be able to get started with it. But then still, you can be able to do like complex tasks with it. And also, if you want to have, let's say, a single input into your neuron, you can use the sequential API. But also, if you want to, let's say, have like multiple inputs and multiple outputs, still they can give you things like functional AI that you can work with. You can even use functional AI that you can use. You also have things like model multiclassing that enables things like dynamic and Python model building. So the key thing you can take from Keras is that it allows you you can be able to build things you can start from a small part and build things. You can also even be flexible, and it can also be powerful. And today, in Keras core, it's as flexible as you changing the backend of what you're having. By backend, I mean you changing the different libraries for deep learning that you can use. So originally, Keras was multi-backend. You had Keras maybe as a UI, and then you had things like Theano and TensorFlow on the backend side. Then at some point, we just had Keras and TensorFlow. So you're just using Keras and TensorFlow with it. In fact, you could access everything in Keras from TensorFlow. But today, Keras again is multi-backend in the sense that you can have Keras as a UI and then change the different backends that you'd want to change, from PyTorch to TensorFlow to JAX, depending on the one that you want to use or the one that makes sense for you. Okay, and you have things like Keras CV, ideally, which is a toolbox that allow you to access different computer vision components, and you can be able to still have the layers and do data augmentation, ideally flipping your photos and whatnot, getting the metrics from the model that you're building, having the model, the losses, and even bounding box. But I'll talk more about this in the next part. But like I've told you, Keras can allow you to do augmentation, and it gives you different layers like augment mix, cut mix, Fourier mix, a range of them. Usually when you're confused of which one to use, you could start with random, I think run augment if you're confused. You also have the ones for object detection, where you can like draw a bounding box in the things that you're seeing. And it supports things like YOLO V8, RetinaNet, and even support, and there are even some newer models in the pipeline. You can also do image segmentation. If you've been watching these self-driving cars, then probably you've seen something like this, where you'd want to capture data from the environment, let's say with a camera, but you don't want to like identify specific things in that environment. So you kind of give them some mask. If it's a person, you can see like a red mask on it. If it's a car, maybe a blue mask on it. Generally, this is called segmentation. And right now, almost everyone is crazy about generative AI. Everyone is excited about generative AI. I know most of you are using ChatGPT. There's BARD, there's Llama, and whatnot. Keras CV also today has an implementation of things like stable diffusion that can allow you to be able to do text-to-image generation. And Keras is being used in different places, including in speakers, self-driving cars. NASA is using it in their robots, a range of use cases. Okay. And we've seen that we can indeed take a photo, have data representation of a photo, and then build our model with Keras to a point where at some point we can have a new photo and ask the model about the photo, and they can tell us that what you see in the photo, it's a mango, for example. We've seen that we can have a model where you can give an input. We've seen that we can have an input to a model and they can give us a mango as an output. But what if you can flip this entire thing to a point where instead of giving them the picture, we give them a text. You give your model a text prompt, and then the model understands this text prompt. And after understanding the text prompt, it generates for you a photo from the text prompt. And of course, different people have been trying to implement this, but the very first one was by Daily. It was the first mainstream text-to-image model, and it's really cool, but originally it was open source, and ideally people couldn't use it. But recently, there's a company called Stability AI. Stability AI. They launched something called Stable Diffusion that's 100% open source. And that means that you can do text-to-image kind of modeling. For example, I was able to do a text-to-image modeling with stable diffusion with that particular text on the left side and have an image on the right side. And probably you're also familiar with the idea of super resolution, where it's probably possible to train a deep learning model to denoise an input image and then turn this noisy low resolution input image into a higher resolution version of it. And do I have the right slides?
Hey Marvin, we're running out of time.
Okay, let me just rush over it. Yeah, so okay. And this is very exciting in the sense that this model does not do this by magically recovering the information that's missing from the noisy low resolution input, but it can use the training data distribution to hallucinate over the visual details that will be present in a given input image. And probably I'll just take you to on how it works. It works in some stages, where on the first stage, you have an input image. Then this input image, you add some noise to it over a series of steps. So add noise again, and again, to a point where you have white noise. And then you can also do a reverse part of it, where you have a noisy image, and you reverse the entire thing with a diffusion model over something called Markov chain processes, to a point where you have a new clear image. And generally, that's how a diffusion process works. You have an input image, add noise to it over a series of steps in the forward diffusion process, then have a neural network, denoise it over a series of steps until you have a final image. There's also something called conditioning, where you can decide on what to have in the final image, where what you could be doing is that you could have a prompt vector or a prompt text. And this prompt text, you project it into a latent vector space. And then you'll have a prompt vector. Then you take this prompt vector, concatenate it with noise. And then after doing that, you'll have a diffusion model that denoises this over a series of steps to a point where you have, let's say, a 64 by 64 latent image patch. And then from that point, you're going to have a decoder that denoises this low resolution 64 by 64 image patch into a clearer, high resolution 512 by 512 image patch. This is how it looks on the code. The first thing you do is install Keras packages, and then instantiate the stable diffusion model, and then get creative with the prompts. And then you'll be able to like have your images, move from text to images. And you can decide to, you can also have like a range of steps. You can see here that I define the number of steps. Where's my pen? Here. You can define like the number of steps, 25, and different number of steps can give you different type of images. The more steps you have, the clearer image you'll have. So you could see here 25, 50, 100. You can also decide on how random the images should be. Let me just show you a quick code before the session ends, because we can't just talk without showing something. Since this developer share entire screen, there it is. So go here. I'll just walk you very fast. I want like run the codes. Let me go back here. Okay. Demo gods be with me. Okay. Stable diffusion. Then you load your libraries. In this case, I want to do something called inpainting. And I can instantiate my model here. Then I put some text somewhere so that I get this image for a lion. Then once I have the image for lion, I'd want to add the lion on this side of my photo. This is a photo I showed you from this point. You can see it on my desktop, but I've just loaded it here. And then you define where you want to see the photo, then be closer to where you want to put it. And then using Keras, you can, of course, generate a fake image like the one I've showed you with this text, a lion with sunglasses looking at a camera, highly detailed, etc., etc. And then after that, you could eventually add that lion in your photo like this one. Original image, define where you want to put the generated image, then have it there. So that one is just one use case for Keras. Where's the slide main? Go there, share. Yeah, and the range of use cases, the one that excited me the most is this one here, where you have a music called American Pie, and then you have lyrics from that music, and then you use Keras CV and Stable Diffusion to generate for you animations from that lyrics. I could just long time ago, I can still remember. So that's how it is. And Keras give you advantages when you're using it, because Stable Diffusion is open source, and the range of guys who are trying to implement it, including Hugging Face and even Keras. But Keras give you some advantages, including easier to use, performance benefits, and even mixed precision, and even something called XLA compilation, where GTIA compile is true. This XLA is ideally an accelerated linear algebra, and there's a way that it makes your model that you're building to have some performance benefits. And the one for mixed precision, it helps you to run computation with 16 bits with float 16, and then store your variables with float 32. And of course, there's the performance benefits that I've talked about. The inpainting I've shown you. But the most exciting part of it is that imagine if today it could be possible to make a Game of Thrones in 10 minutes by just writing down the scripts and having AI invent for you the characters, the costumes, the smoke and battle scenes, just by having watched several similar movies before. Just imagine that. So yeah, that's the power of what Keras can give you. Probably I could take questions. I hope I've not.
Thank you very much, Marvin. That was an exhilarating session. I'm pretty sure a lot of us, learned a few things from that session. If you have any questions, please, you could, drop your questions. Let's have a go at a few of it. We're really running out of time. But why would also do that? I mean, for me, for example, I know very well that computer vision is one of the biggest branch of AI, right? And stable diffusion was a significant, step with computer vision. Do we have any questions? None yet. We're supposed to have a stretch break very soon. So, but before we go for that, I'd like to ask a few questions. One, I don't know. Could we have? Is there anyone that wants to talk? Give us an example of projects they've. Maybe just type example of projects they've built with Keras in the comment section. Let's have a go at it. Especially computer vision. Or do we have people that have used Keras before in their projects? Yes. Is there any yes? Oh, someone has a question. What do you mean by adding noise? Is it making the image more blur, or what does adding noise to the image mean?
So by adding noise, I mean you're making it blurrier and blurrier and blurrier over time. You are using a Gaussian filter, or you're using, let's say, a Gaussian kind of distribution, and you add it on top of the image over and over again. And every single time you add the noise, you're going to make it blurrier and blurrier and blurrier to a point where at the end of it, you have a complete white noise in your photo where you can't really see what's in that photo. I think you're on mute or something. I lost you. Can you hear me?
Yes, I can hear you. Someone is also asking for your email. I don't know if that's something you want to share here, or if they could just reach you on your social media profile.
Yeah, you could reach me through @ngesa254, but I could drop my email as well. It's ngesa.marvin@gmail.com. Yeah.
Someone also asked, please share the journey or roadmap for someone getting to build such advanced model GANs. I think that's an interesting question. I'd like to hear too.
So just to note, I'm talking about generative AI using something called stable diffusion, which is different from GANs. In fact, stable diffusion is more efficient today than GANs. But I think the journey will be, first of all, understanding the basic principles of what machine learning is and what deep learning is. Once you have the key concepts of what a machine learning is, then you can move from that point and go to even the intermediate and expert content. For example, understanding like what am I doing when I'm building a model? The code may look like small in size, but what you have in between those code is a lot of content in it. How do I extract features? How do I build my model? How do I reduce the loss from my models so that I have like a good model? And what am I doing with all these convolutions? How am I? What's the effect of adding a filter to my image? And once you have those concepts, then you can probably know that if I add a lapulation, let's say noise or filter to my image, this is what will happen with it. If I add this kind of noise to it, this is how it will blurrier, or I'll be able to have like horizontal lines in my image, or enhance the vertical lines in my image. And then if you know those concepts, then you can go and be able to build on top of it to a point where now you can go to generative AI and even diffusion models.
Yeah, that's a great response. I might also want to add that if there's anything I think is really helpful for a career in AI, it's understanding the basics. This would help really down the line. We have to go for a stretch break right now till 1:45 GMT plus 1. And then we'll have a session with Robert John on Keras and TensorFlow decision forest. So from here, we have a few other questions. Okay, but we're out of time, so we might have to go right now. Thank you very much, Ngesa Marvin. It was very informative, and I'm sure a lot of people are inspired by what you do.
Thank you for listening to me. Thank you for having me. Yeah.
Thank you. I see a question from Albert. Is it possible to extract only needed features using filters the image, for instance, a dog in a model, and then you can extract dogs to exclude? With computer vision, extracting is of course part of the. So it did mention something about object segmentation earlier. Object segmentation is a branch of. I think what you're asking is about object segmentation. It's a branch of AI where you can, let's say you have a cup, right? There's image detection. You want to detect what is in the image, right? And then we have a cup. But let's say you're building a robot that wants to fetch water in the cup. You want it to know where it can put water in, where it can hold, and all that. So extracting features from images it's there's a lot of branches basically that this is what it's on, and I just had to jump on that. Our stretch break will be back very soon. 10 more minutes. Thank you. Look forward to seeing you soon. Hi everyone. While we stretch, I thought I would also jump in and ask a few questions. If anyone would like to respond to it, I believe we should not be too far from our screens. They're just basic questions I'd love to ask. Uh, are there folks there? If you're there, send me hi or send me a yes. We're here. I'd love to know. Oh, great, great. There's a lot of comments about Ngesa Marvin. That was an enlightening session. So someone did ask about parent programming is just this. Yeah, for AI, well, you can't really run away from Python for so much. There's there's a glass ceiling if you do not want to do Python. So Python is a favorite language. It's the AI language for now. There's of course there's a few others. While we also do this, I also have a few questions. So for those that have trained models before, how do you prefer to train models? Is it on CPUs? Is it on GPUs? On TPUs? Please drop your comments. And what's your most interesting project? Hi, Robert. Are you? Oh, amazing. Our next session would be Keras and TensorFlow Decision Forest. Robert has worked with databases and developed enterprise software for over a decade. He currently works with all things data, from engineering to visualization to machine learning. He recently started working with embedded systems and TinyML, and is eager to see widespread adoption of embedded systems in Africa. Amazing. In the past, Robert worked as a software engineer building systems for finance, telecommunication, utilities, and energy vending. Uh, this is an amazing profile. This is an interesting profile. Robert looks forward to a time when Africans will design and build their own embedded systems with machine learning capabilities. He contributes to the developer ecosystem by speaking at events, hosting meetups, code labs, and tutorials. He also writes articles on Akstar.io, Medium, and his personal blog. GCP also is a mentor with Google for Startup Africa Accelerator Program and is co-organizer of Google GDG Cloud Developer Community in Kaduna, Nigeria. We have an erudite on our hands. I'm sure we are in for something very interesting. I hope a lot of our folks are not too far from your screen, and so they could, come in right away so that we could continue with our next session. Thank you for being here for us, Mr. Robert John.
Hello, everyone. Welcome to this session. And the topic is exploring machine learning wildlife with Keras and TensorFlow decision forests. So actually what we're going to do is we're going to take a look at the IRIS dataset. And if you're not familiar with what the IRIS dataset is, we will get to that in a little bit. Now, just for starters, what you get is when you hear Keras, especially for people who worked with Keras for over 2 years, what you think about when you hear Keras is you think about deep learning models. And we know that in machine learning, we have, what we might call ML models or linear models, and then we have deep learning models. And traditionally, deep learning models are specific to things like computer vision and natural language processing, which we've seen with the two previous speakers. So when you think of natural language, then you want a deep learning model. When you think about computer vision, then you want a deep learning model. But let's not forget that we also have lots and lots of tabular data. We have data that isn't specific to speech or natural language and isn't specific to computer vision. You have tabular data, right? One popular one, for instance, is the Titanic data set that we use frequently. The IRIS is also another one. So imagine yourself at a data science competition, and we have lots and lots of these. Could be physical, could be virtual. Kaggle is popular for hosting ML competitions. And there are lots of other programs where you might have a competition as an entry requirement. Now, you find yourself with a data set, and in this case, it's a tabular data set. Let's even say it is balanced, it's been cleaned for you, you have a good number of samples, no missing data, no NAN. You don't really have to spend time pre-processing the data. And so what do you think? Typically, if we are doing tabular data, you wouldn't think about Keras. You probably wouldn't think about TensorFlow. Of course, if you know TensorFlow version 1 before version 2, you might think of maybe using it for, maybe with a linear estimator or something like that. But suppose in the days of conversational AI, you go and you ask BARD for help. And suppose you go and put in this sort of prompt, right? You ask it to generate code for you using pandas, using sklearn, because in the past, if you had to deal with tabular data and you wanted a simple life, you would go with sklearn and NumPy, of course. And you ask it to help you perform classification because you're dealing with the iris data set and you want to do some sort of classification. And because sklearn lets you create decision tree classifiers, you decide to write code for a decision tree classifier as well as a random forest. They're not the same thing, but we'll get to talk about them. And you give it this prompt and it responds. It writes out a script for you. It imports the necessary libraries. You can see here it's importing pandas, NumPy, sklearn or pre-processing. You're using standard scalar, again, because you want things within a reasonable bound. And then you import your decision tree classifier, and then you want an ensemble, so you import random forest classifier, and you do the usual, right? From pandas, you make use of your read CSV and you import that, and you create a train test split, and then you scale the features and do whatever. Now, you've got your code, and you assume that you're going to train something pretty quickly. So what do? You go brew a cup of coffee, and you sit down and you're waiting for your code to execute. Now, what happens if the code isn't done training your model in the amount of time that you expected? What then do you do? Of course, you go back and you look at your code and you try and evaluate your decisions, what's going on there. So, first of all, you're making use of pandas. And what are some of the benefits? Well, it's easy to use, it's easy to learn, it's widely supported. But what are some of the challenges? Traditionally, it's slow when it comes to handling large data sets. There's been somewhat of a fix for this in Pandas version 2.0. It's expensive on memory. Again, there's somewhat of a fix. But then, there's this question of consistency across platforms. So, remember that a lot of the time with ML experiments, you want things to be repeatable. But with pandas, it's not necessarily the same as you go from one place to the other. Of course, we could extrapolate all these and say, put this in a Docker container or something and share that file. But let's not get ahead of ourselves. You're making use of scikit-learn. What are the pros and cons? One pro is that it is versatile to use with a beginner-friendly design. It's efficient in the development of simpler ML models. Really, even a lot of people who don't understand ML theory can get along with scikit-learn. So it's really good. It's free and open source. But what are some of the challenges? First, it's not performant over large data sets. And then model interpretability goes out the window. You can't even work with imbalanced data sets. Of course, it just means that you need to introduce an extra layer. In this case, something like IMB learn for imbalanced learning. And then let's move forward, right? So we know that we've got code that could work on small data sets, but when we get to large data sets, we start to struggle. So what is the solution? And now we have TensorFlow decision forests. Interesting name, kind of a mouthful, but TFDF is really what it's short for. And so it lets you work with different types of models that are tree-based in TensorFlow. It's powered by a library called the Yggdrasil Decision Forests. That's the backend for it. You can look it up. I don't really want to go into the details of what Yggdrasil means, but it's from Norse mythology, and it's the horse that Odin rides. Yeah, the rest of it, I mean, depends on how geeky you feel. But anyways, just like everything that involves TensorFlow and Keras, it's a very simple process: definition, training, validation, tuning, testing, and model interpretation at the end of the day. You're working with Keras, so all of the features of Keras at your disposal. Of course, you're not doing deep learning. And what's the biggest benefit? Well, it's the same benefit that TensorFlow brings and Keras brings on top of that, and that's GPUs. You have access to application-specific integrated circuits, GPUs, TPUs, that will speed up your processing. Now, usually we leverage GPUs and TPUs when we're talking complex arithmetic, linear algebra, again, images, videos, natural language. But when you're dealing with a large data set, GPUs also come in handy because they will speed up your training process. So there are all sorts of, there are a bunch of options, models that you have with TFDF. And the easiest thing to do is to just go to tfdf.keras and just take a look at the documentation. So it will tell you what the various options are. But here we can see, for instance, that we're dealing with a random forest. So with the random forest model, we have an ensemble of decision trees. And what that means is that your forest is made up of trees, different trees. And the reason why it's made up of different trees is it goes back to what machine learning is. Machine learning, by its very nature, is stochastic, right? You start, and you saw that with in Marvin's presentation, where he showed you the equation for a model. Y is mx plus c, right? The y is what you're trying to determine. And in your training data, y is there, it's fixed, and x is fixed, right? But that m or w, the weights, are what you're trying to learn. And what happens is you start with a random set of values, and then you upgrade them using the gradient update rule. So because you start with random values, there's a bit of randomness, meaning that if you train the same model different times, you'd end up with slightly different models. So what you do here is, instead of training one decision tree classifier and then using that for your predictions, and usually they're good, but you get a better outcome if you train multiple decision tree classifiers and then you use a voting method, which is what gives you that forest now. So, trees give you forests, and that's what the basic analogy is. And so if you make use of a random forest, you have an ensemble of decision trees. You have branching out based on different parameters, and it's random. So that's why you can see that, the trees kind of look different, and then they're kind of weighted slightly differently. And then you have a majority voting on the chosen result. If you don't want to work with the random forest, there's also a classification and regression tree model. That's called the CAT model. So you can use it for either classification or regression. Again, it will give you an ensemble of decision trees. And then you can also do gradient boosting. So, there are all sorts of bagging and boosting techniques when you start to deal with trees. This goes, this is different from your linear regression and logistic regression. Again, it's different from your neural networks. But, when you get to trees, you get to bagging and boosting. And so you can see an example of that here, where you start with your data set, and then you have a tree, and then you test it, and then you can train another tree. You can train multiple layers based on the output of the previous layers. This is different from your weighted scoring method. So your weighted scoring method is saying, if I have 3 trees, then whatever the majority result is from those 3 trees is what I take. But when you do a gradient boosting, what you're saying is, if I have 3 trees, the output from those trees become inputs into a new model that I will train, and then I will take the output for that. And you can do that multiple times. So that's why this image looks slightly different from the previous images that you've seen. But essentially, you'd still call it an ensemble. Now, with TFDF, you're also able to visualize your trees. Typically with Keras, you're able to visualize any model. So here, you're also able to visualize your model. You can see the hierarchy. You can see the trees and how they weigh things, right? So this is what you would call your model explainability, meaning that it's not a black box. You're not just, sitting down and saying, oh, I trained a model and it performs this way, but I don't really know why it's performing this way. You're able to say, oh, I know what exactly is going on with this model. I can see that it's taking this feature and it's weighing it this way. And then you can decide whether or not that feature is actually relevant, and whether you would like to keep working with that feature, or whether you'd like to drop the feature or engineer the feature or whatever, right? But at least you have some visibility into what's going on with your model. And so here we see an example of a visualization for our random forest model. We can see a similar thing with, again, the random forest model. Now, I said I was going to talk about the iris data set if you're not used to it. The iris data set is a set of measurements of flowers, 3 different types of iris flowers. And the difference between them is the size of there's something called a petal and a sepal in flowers. For those of us who didn't do biology, the sepal is the outer parts of the flower, which is the green part. So there are measurements for the length and the width, and then the petal is the part that looks like a flower, and again, measurements. So there are 4 measurements for every flower, and then that's being used to then say, can you accurately classify an iris flower into one of 3 subclasses based on certain measurements? That's really what the exercise is about. And so working with that data, you can see where a classification is done based on the petal width, another classification is done based on the sepal length, right? So that's how this this tree has been broken down. And so let's take a look at what the code looks like. Let's take a look at what the code looks like in okay. So what you've got is your TensorFlow decision forest isn't part of your standard Keras library. So you need to do a pip install for it. And that's what's going on in this example. And then once you have that, you'll import your standard TensorFlow, right? And then from TensorFlow, import Keras. And then you'll need to import your TensorFlow decision forests. And then we have our usual suspects, pandas and NumPy and matplotlib, just for some visualization. Now, if you read in that iris data set, which you can find from Kaggle or from some other sources. You might need to do a little bit of transformation, but basically this is what you should get. What you're trying to classify is the species. You're trying to find your species, and you have 4 measurements: the sepal length, the sepal width, the petal length, and the petal width, right? And so you can read the data in, which we've done with pd.read CSV, and then df.head, which is what is giving us this. I'm just flying through the code because you've read enough Keras for today, and there really isn't anything new. This is matplotlib, and what you're doing is you're visualizing, and what you can see here is you can have this as lines or you can have this as dots, but what it does for you is it's plotting the different values of the different columns in the file that we just read onto a chart. And what that does is, depending on how much experience you have, you might say, for instance, oh, I can see that there's a bunch of sepal length readings that are down here. There's another set that looks like it's up here. You can do that with sepal width as well. You can see some are here, and you might be able to figure out some here. But it's much clearer when you come to the petal. So with the petal, you can see that clearly there's a bunch here, there's another bunch here, and there's another bunch here. And so this lets you know that, yeah, you can actually find a separating hyperplane or some way of separating these things into various classes, right? And so you can go ahead and do a split. So we use NumPy and random, and then based on that, we can take indices that fall within our test split that we're interested in, which we generated here. So what's in the indices falls in one group, what's outside of the indices falls in another group. So we're basically just using indices to split our training and test data sets. And then to work with decision forests, we have to work with TensorFlow data sets, right? So we have to take our data sets, our pandas data frame, and convert to a TensorFlow data set. And that's what we have here. Our training data set is TensorFlow data sets.keras.pd data frame to TF data set. And then we specify our pandas data frame. And we also specify our label, right? And then you can just go down to your model experimentation. And this is your standard Keras. With one difference, you do not need to define your model. So remember, if you're working with Keras, especially if you're not doing transfer learning, you typically will be defining some sort of sequential model. In this case, that model has been defined. So what you do is you just create an instance of, in this case, we're creating an instance of the random forest model, and we call that model 1, right? And then you can just do model 1.fit and pass your training data set in there, and you will end up with a trained model. And this is our history, so you can take your history and you can inspect your history afterwards. And recall that I said that there are different types of models. So what we're doing here is we're creating an instance of the random forest model and fitting the data to it. We're doing the same thing with the gradient boosted trees model and fitting the data to it. It's the same thing. It's kind of even similar to what you would do with scikit-learn, honestly. And then again, the CAT model that we talked about, we're fitting data to it. And you can read some of the output here, but you've got your history, so you can go and play around with your history as you usually would. And this is our visualization, as we've seen, right? And what we do is tf decision forest dot model plotter dot plot model in Colab, and then you pass in the model that you trained, and then you can specify some other parameters. Here we're specifying max depth equals 3. And it's the same thing, just with different models, right? Model 1, model 2, and model 3. Now you've got your automatic hyperparameter tuning for TensorFlow. So, typically there are some decisions that you would have had to take. What's the optimal number of trees to use in a random forest? there's no simple answer. So, you might use some hyperparameters to specify some things, but here you can use your decision forest.tuner.random search, right, to create a tuner, and then you can pass in some parameters, the number of trials that you want, and the kind of search space that you want to work with and things like that. And then you can go train a model again. And the difference now is you pass in a tuner. So previously we created an instance of the model, but we didn't pass in a tuner, and then we just fitted the model. Now we can do the same thing, but we can pass in a tuner, and you'll still have your history, and you can go do things like run tests, validate your model, look at how quickly it's improving and things like that. So that's decision forests for you. And that's really all there is to decision forests. You're working with tabular data, not binary data, and instead of working with scikit-learn, not having access to your GPU and all of the benefits of TensorFlow and Keras, you can simply make use of TensorFlow decision forests and import the particular make use of the particular models that you're interested in, and that's it. So one question is whether you will get you get access to the slides. Yes, the answer is yes, you'll get access to the slides. I will share Norse mythology tree, that connects Ahmed, Norse mythology tree, so you'll get the slides. Thank you, and I believe we have time for questions because I went faster this time around. So who's coming back on stage? Oh yeah, Peter, how are you?
Hi, Robert. That was an amazing session, by the way. I've been fine, very fine. Thank you. Thank you. How have you been?
Good.
Yeah, I'm going to steal your last slide. For my future talks, if that's fine by you. Okay. All right. I don't know if people want to ask questions, so we can give a few minutes for that before we move to the next panel session.
Yes, it's the Norse mythology tree that connects the 9 realms. So that's Yggdrasil. Peter, do you have access to some of the questions?
Okay. Yes, I can just read them out. Okay, someone is asking if we are. What does large data sets mean? That's one question.
Okay, yeah, good question, Ahmed. So large data sets is, nowadays we probably just call it data, right? So there was a time when the world didn't produce a lot of data, but nowadays the world produces quite a lot of data. Think about it from the perspective of if you're a bank, for instance, how many transactions are your customers carrying out on a daily basis, right? So if you needed to do something, and banks do all sorts of things, predicting loan default, predicting customer churn, and all sorts of things, you're going to want to look at data, right? If you then said, let's look at transactional data from the last 1 month and predict churn, it's going to constitute a large data set, right? Especially if you've got tens of millions of customers doing transactions every day. And we do transactions, right? If you go out, you could use your card on 5 different terminals in one day, and imagine so many customers doing so many things. And it's understandable. If you are in Nigeria, for instance, at the end of every month, we just have this clog in the payments network because everybody is suddenly transacting. That's what a large data set means.
Okay, another question is, and I think this one is interesting, can decision trees overfit?
Yes, decision trees do overfit. So the norm is there's something called pruning. and it comes from gardening. So you can prune your trees or just minimize the depth of the trees, so you just ensure that the model doesn't overfit. But yes, trees do overfit.
All right, cool. One question from Adebayo Yanolua is, how do you access the model? What metrics are available?
So the same way you access every other TensorFlow or Keras model. So, the way you have model.fit is the way you have model.predict and things like that. So all the standard methods are available to your model.
Okay, I think that's all. That's all for this session.
Okay.
All right, super quick. We'll commence with the final session for this event, which is a panel session. So I'll welcome Robert John, who's already here. I would also welcome Marvin. How's it going, Marvin? And then I'll also, very fine. I'm Marvin. Hi, Diana. How's it going?
Hello, it's good.
Nice. Awesome. Okay, so without further ado, I'll just kickstart, right? So the idea is we're going to ask a bunch of questions from several different categories. So the first category is the general Keras questions, right? And then we've got another category for Keras CV and computer vision particularly. And then I think there's also another bunch of questions for NLP, Keras NLP. And then there's a final set of questions for, community and collaboration, right? So you guys can answer, it doesn't matter in terms of who takes the answers. It can be anybody that, wants to answer can answer. Or I can just call, if I like decide to. So first question, before Keras became a part of TensorFlow, right? What was it like? And now that Keras is a part of TensorFlow, how do you sort of like envision what the future integration of these two libraries is? What is it now? What was it before? And what do you think it will be in the future? That's like first question.
Probably I could start. So originally, Keras was having a multi-backend in the sense that Keras was like a UI, and then in the backend, you had technologies like Theano and TensorFlow behind it. And then at some point, they changed the strategy, and Keras was more integrated into TensorFlow to a point where to access Keras, you could use TensorFlow to access everything from Keras. Then beyond that, today, we're also having a multi-backend Keras back again, where you could have Keras as a UI again, and in the backend, you could run JAX, you could run PyTorch, and you could even run TensorFlow in it. But the key idea has always been to make it simple, to make it flexible, and generally beginner-friendly. And I'm also seeing a push to have more community behind it, and also generally have more people use it.
Cool. Amazing. Thank you for that, Marvin. All right. So my second question, which is so like under the general Keras questions as well, is, following the inspiration of Keras itself, how would we answer a question of why Keras was created? What inspired the framework itself, right? And I know that we've tried to answer the same question in several different sessions, but if you wanted to give a one sentence answer, right, single liner, what was the specific inspiration of why Keras was created? Anybody? I call someone.
Yeah.
Okay,
Yeah, I think if it's in one sentence, I'd basically just summarize looking for simplicity and ease. Yeah, I think that would basically just be it. Yeah.
Okay, cool. And are we going to say that Keras has been able to achieve that that journey, or how about we going to say the journey of Keras how has it been able to, achieve that particular sentence I just said? Diana.
Basically, I think, yes, it has so far, because one, the reduction of codes, like for example, the Keras NLP, right? You don't have to do the pre-processing. It comes part of, the task model that has been created. So yes, it has in quite a lot of instances, like just one that I've given. Yeah.
Awesome. Thank you very much, Diana. Okay, my next question is: what are some key features that differentiate Keras from other deep learning frameworks, right? And how do these features benefit developers, right? There's certainly some key features for Keras that separate Keras itself from other framework, right? And how do these features, how do they benefit machine learning engineers, data scientists, and different category of developers that write Keras, from day to day. Robert, do you want to take that?
Okay, yeah, let me try.
Okay.
Because again, I think it depends on the interpretation of the question. So first of all, if we go back to the fact that Keras was, and I think it was Marvin that put it that way, it's kind of like a UI on top of an engine. What it did, or what the differentiating feature is the fact that it lets you define your model in a simplified manner, but choose your backend to give it the power that you want. And to understand that, you can look at how Keras defines models and compare that to how PyTorch defines models and how TensorFlow itself, TensorFlow version 1, right, defines models. And the interesting thing with TensorFlow version 1 is there's TensorFlow, which was really low, how would I put it, low end, kind of like working with NumPy. And then there was TensorFlow estimators that made things easier, but they were still not as easy as what Keras is. So in terms of that differentiation, there's that. But the good thing also is that Keras gives you the power to go what we might call high level, to say, if what you want is just a simple life, I just want to come in and define a model, right? You can go in and use like your sequential model, but also gives you the power to define really complex models, right? So when you think about some of the state-of-the-art models, they are not defined using the sequential model. It's impossible to define them using the sequential model. So it lets you go high, really high end, and it lets you go high level, and it lets you go low level, depending on what it is that you want to do. But it is still simple. It's still relatable. And sometimes, people, I think there was a point that when people said, oh, no, like this definition doesn't make it Pythonic, whatever that means, but it doesn't look like you're writing Python. It looks like you're writing something else. But I think in the end, what really matters, especially for the creators, was whether this was something that you could take, look at, and still remember afterwards, right? And the beauty of the sequential model is all you have to do is just keep adding layers. And no matter how much time you spend without defining a sequential model, when you come back and you try to define a sequential model, you're not going to be thinking, oh, do I need to create constructors, destructors, this and that and that? No, it's really just put two square brackets and start adding your layers and separating them with commas, and you have a model. And once you're done, add your optimizers and fit your model. So I hope that helps.
Yeah, it does. I mean, you want to add something?
Yeah, I think John has really explained it well. I could just add that probably if you compare like what the other things that we have in the industry, or the other framework that we have in the industry, you realize that Keras is kind of, I don't know if I'm biased, but it's kind of well documented and supported. You have lots of examples, you have lots of tutorials, resources that you can use to get started. And I think it's also actively maintained. The Keras team is actively maintaining it, but also, Keras is open source, so people are also able to contribute to it. And then I also want to emphasize on this new thing that's coming on Keras 3.0, that it's multi-backend. That means today you don't have to be locked to use, let's say, just TensorFlow. You could decide to use any deep learning framework that you prefer. If you want to JAX, you go to JAX. If you want PyTorch, you go to PyTorch. But just have Keras as a high-level API, and then all these ones as a backend for them. So you can switch backend the way you want.
Awesome. Thank you very much, Robert and Marvin, for your addition. Okay, so I think I have a very curious question, and then it's this question is going to be more of a discussion, right? And then I think that multiple persons can like talk about their own perspectives of this particular question. Can we discuss some of the challenges and considerations in maintaining Keras, right? And seeing Keras as a user-friendly interface, whilst in the background it is trying to spin up and support complicated deep learning tasks, right? And then because we understand the theory of what happens, in deep learning algorithms, right? How would we describe the challenges that come with trying to think of the situation of persons that are actively contributing and actively supporting Keras, right? What are the challenges going to be right now for them? Anyone can answer the question.
Marvin, do you want to go first?
Yeah, I could try. Maybe you could say performance. Of course, while working with these models, you're dealing with a range of parameters. And deep learning models can be, you could say, computationally extensive to train and even to deploy. So there's that need to address, for you to have like a good performance for it, then I think that performance could be a big issue to it. You could also say right now there's a push for explainability, that the models that you're having, you need to have like an explainability for them. And these deep learning models, there is kind of a black box for them. It's difficult to understand how they make decisions. So I think it could be difficult probably to probably trust them or something. Maybe there's also visualization.
Yeah,
as well.
Yeah, cool. Yeah.
Okay. So let me add to that.
Okay.
And I should start by issuing the caveat that I'm not one of the contributors to the Keras framework. But I think that one of the challenges would be in even deciding what goes in and what doesn't go in as a feature, right? So if you want something that is user-friendly, the question becomes, who are the users and how do you determine what is friendly for them? And part of this has been the challenge with TensorFlow itself, right? The framework, and in saying, do we add estimators? Is Keras optional, or is it the first thing that you see? And that was how Keras was brought in, and there was a huge conversation back then when Keras was announced as the new face of TensorFlow 2.0. And then along the way, JAX and Flax got introduced. And then the question became, is JAX and Flax going to supersede Keras? And then there had to be the understanding that no, but researchers work differently, and so let's have something different for them. And so that's what you have nowadays, right? Where JAX and Flax is mostly for the research community. So it's mostly a question around, what do the users consider to be user-friendly? Which models should we make available for transfer learning, right? Do we make all the state-of-the-art models available? And that's also where you have things like model gardens, where you can find models that aren't existing and contribute them there. The same thing with TensorFlow data sets. What are you able to import immediately, directly, versus having to go do some work, right? It helps with teaching, it helps with education. But those decisions are some of the difficulties and the challenges that go into maintaining something like Keras.
Okay, awesome.
Back to you.
Yeah, makes sense. Makes sense. Does Diana want to have anything to add?
Yeah, so I actually think I dropped off. I don't understand why, what happened. But mine, I think it's more on an emphasis in terms of the computational ask and resources, just like what the two have just confirmed and said, to maintain and actually, have that first and for us to have an ease of usability, then there's a lot of work that is going at the background to actually maintain it, and it's not cheap. Yeah, so I think that is one huge challenge that Google is eating up. Yeah.
Mm. Okay, awesome. Really awesome. Awesome. All right, so next question, and this question would cut across both Keras CV and Keras NLP. Right. So for both Keras CV and Keras NLP, are there any exciting and really exciting Keras CV projects or Keras NLP projects or applications that are that we're very, very intrigued about, and do you want to do like an overview of any of these projects? Anything that Keras has done, or that's currently built with Keras NLP or Keras CV that anyone wants to like talk about, share the excitement, and stuff. Anyone?
Yeah,
Sure.
I could talk about it, especially if you're coming from a background of electrical engineering.
Okay.
There's a combination of electronics and AI, and seeing that companies like Waymo can have cameras that collects data from the environment, and then they're able to process this data, not just from cameras alone, but from radar and a range of sensors. And they're able to enable Waymo to be a self-driving car that's moving. In fact, Waymo runs on Keras on it. And then the other one is Google Home, that you could just talk to Google Home, and then it listens to you and execute what you want. But I also know my colleagues have some other exciting use cases.
Cool. Okay, anyone else?
So for me, I think definitely with Google Lens, right? With the use, and I feel like that to me was something what I was really looking forward to, and something that I've always wanted to have. Just taking a photo and then it kind of generates more information about it just by a photo, and that's it. So yeah, Google Lens I think is one good project that came into that. And then finally, of course, now the text generation aspect on your simple Excel sheets. I feel like that was, especially for the finance team, I think they're really quite impressed by what Google has done in terms of the sheets, in terms of, you're typing out a formula and it auto-completes. So that aspect of just text generation really helps quite a lot. Yeah.
Okay, cool. Thank you very much, Diana. Robert, do you want to add anything?
I could add one that's very, very exciting that I keep on talking about every time. And it's this one for generative AI. There's a demo I had on my slides. I wasn't able to show it because of time.
Why?
But
Why? Why
because of time.
Okay,
because of the time. But there's someone called Ian from Google. It was able to show how you can pick the lyrics of a music called American Pie, and then use those lyrics with Keras CV and Stable Diffusion to generate animations from the music, to a point where you can now attach the lyrics of the music with animations and have the animations doing what's in the lyrics of the music using Keras CV and Stable Diffusion. Yeah.
Impressive. Cool. Okay. Robert, do you want to add something?
No, please go on.
Okay, awesome. All right, so next question will be, so currently this is particular for Keras CV, right? What strategies or techniques does Keras CV employ to handle challenges like data augmentation, transfer learning, model interpretability in computer vision? Okay, anybody can take that. Should I call
So
someone?
I think
Okay.
we're thinking because of the choice of words, in terms of strategies or techniques. I think that to understand these frameworks properly, the best thing to do is go to the docs and say, what are the layers that this thing supports, right? Or what are the transformations? But Keras, everything is a layer, right? But when you see the layers, you'll know what the transformations are. You'll even know what the parameters are that it takes. So you know what sort of customizations you can have in place. So you can't really work with these things or understand them without having a documentation page open, right? Every time you want to start working with these things, you really want to just go have the docs open. Once you have the docs open, it's easy to figure out what's going on, right? If you're wondering, does it do flip? Does it do reflection? Does it do, rotation, whatever? All of those things you will find out in the docs.
Cool. All right. Cool. Makes sense actually. So does anyone else have any addition to this particular question?
I could add and say that also, of course, if you go to the documentation, you could see that Keras also provide for you augmentation layers, like random flip, augment. I mean, the range of them that you can use for augmentation, which could help you to reduce things like overfitting. And then also, you talked about transfer learning, and I know that Keras provides something called backbones, and even pre-trained models that you can use to train your model, and that way it can make you easily do transfer learning and reduce the time you take to build a model.
Okay, thank you very much. All right, so I think I'll ask a few more questions. Do we currently have any, recommended best practices for effectively using Keras CV or Keras NLP to tackle real-world problems? What is real-world computer problems that are recommended NLP? Diana, do you want to take this question?
Maybe I can speak on NLP, not on Keras CV. Yeah, so for me, in terms of NLP, definitely, it can be quite dangerous if you do not define and understand, right, your problem, because you're working with pre-trained models in Keras NLP, right? So if there's a certain, and pre-processing really matters a lot, if there's a certain aspect or need that needs to be tuned to be special in your data set in terms of the pre-processing, then do the pre-processing aspect. So that's one good practice I can say. Really understand what you're trying to do before you even proceed to use Keras NLP as it is, and defining whether you actually need to perform the pre-processing prior, or which model that you want to select out of what is available, right? So definitely understand the problem you're trying to tackle in your real world problem before you actually select a model or proceed with Keras NLP and its functionality. Yeah.
Okay. Very, very, very helpful. Thank you very much, Diana. I think that we'll just jump to our final question for this panel session. And this question is more related to, the community for Keras, right? Are there any advices that we would have for individuals or, developers who want to contribute to Keras, whether through code contribution, whether through documentation or knowledge sharing? Do you have any advice for people who want to get started, who want to contribute, who want to share knowledge about their own Keras experience as well? Robert? Okay, yes, Diana,
Okay.
continue.
Yeah, maybe I can take this one in terms of advice. So if you want to contribute, definitely my first advice, go ahead and do it. Choose what exactly do you want to contribute on, right? Even raising a simple issue on GitHub and having the Google team address that, it helps quite a lot when I'm developing and I run into the similar issue and I can search for it and I see it appearing on GitHub, on the GitHub official page and seeing how it's actually been solved, right? So if you have a bug or an issue, put it on Stack Overflow or on the GitHub itself. And then in terms of knowledge sharing, platforms like this, right? What GDG Lagos is doing, sign up, share the little that you've learned. No one expects you to be perfect, right? Just be free, share, let people learn, and then also learn from each other. I think that's what I can say. Yeah.
Awesome.
I could
Anyone
add,
else? Sure.
I could add on top of what Diana said, and
Okay.
just emphasize that you could just start small. Just start, but also just start small. By starting small means you could even fix small typos in the documentation. And also be patient. You don't have to, sometimes maybe it could take you like some time before you contribute to all this. So if you try to make a contribution and it gets rejected, don't feel dejected about it. So be patient and just start small.
Okay. Thank you very much, Marvin. Robert, do you have any addition?
No, they've said it all, really. Just do it, really. Yeah.
Okay, thank you very much, Robert, Marvin, and Diana. I think with that, we've come to the end of the panel session. Super helpful, extremely helpful answers. Thank you so much for these sessions. Thank you so much for the time. Thank you very much for the answers as well. So I think we're done. I don't know, Ada, you can take the floor from here.
Okay, thank you very much, Yinka. Thank you very much, Robert. Thank you very much, Diana and Marvin as well. Also, thank you very much, Lekon. And thank you to everyone who stayed till the end of this session. This was a very, very insightful session talking about Keras and NLP and everything around machine learning. I also saw some questions, people who asked about, if they could join any ML-related communities in SSA. Yes, we do have this Keras Community Day event is focused on bringing more awareness to Keras technology and also as well as bringing more awareness to ML communities within Sub-Saharan African region, just like GDGs, GDSCs, and also TensorFlow user groups. So if you would like to join a community that's focused on ML, that's machine learning, or a field around that, feel free to join a GDG community around you. You could visit gdg.community.dev. If you would also like to join a TensorFlow user group community around you, it's as simple as visiting tensorflow.org/community/groups. Once again, thank you everyone for joining. This was very, very insightful. This recording is going to be available even after this live stream session. So if at any point in time you want to come back to this, to either recap on either of the sessions or connect to any of the speakers, you can feel free to do that on here. Some people were asking questions about the slides. If you are connected to or you're a member of the GDG Lagos community, we will be providing the slides on there after this live stream, and they'll share to everyone who has RSVP'd on there. You can also follow GDG Lagos on any of the social media accounts with GDG Lagos, Lagos. Next week, Saturday, we'll be having the French edition for all ML engineers, experts, and enthusiasts in Francophone regions, that's those who speak French. We'll be having the French edition of this same Keras Community Day. So if this is you or you know somebody who is a French speaker and is interested in machine learning, please feel free to invite them. It's going to be this same channel next week, Saturday at 12 p.m. West African time. Thank you once again, and please do enjoy the rest of your Saturday. Bye, everyone.